Okay guys, so this is the problem we have. We are going to solve this problem. Now let us see what is the question. It is given that we have to find the following things for the given truss element. Now the figure is shown here, and these are the three following things which we need to find. First is nodal displacement, second is stress in each element, and reaction at the supports. Now don't worry, so far I have not told you the formulas for all the three. Now as we solve the numerical, we'll get to know the formulas for all the three, right? So it is very basic and very simple problem, but the only thing is it is lengthy. Like there are so many steps, so you have to focus, and that's it. There are basic calculations. For that you need a calculator, right? Now what will be given in question? Let us see now, right? So the figure will be given in question like this. The coordinates will be given. Now let us see, there are three supports, right? So this, whatever is seen, you can see in the video, is the support. Now this is a roller support and this is a joint, right? And let's see how many elements are there. Now this is one bar, so one element, second bar, second element, third bar, third element, fourth bar, four elements, right? Now there are four elements. Now let's see how many types, how many nodes are there, right? Now node is a point where two elements meet each other. So this is first node, two elements are meeting. This is second node, two elements are meeting. This is third node, three elements are meeting. Now two and more elements can also meet. So this is third node and this is last. 1, 2, 3, 4. Four nodes are there. So if four nodes are there, four coordinates will be there, right? So for each node, one coordinate. So I am assuming this, or they have told that this is your origin 0, 0. This is 40, 0. Now since this is a straight line, your y coordinate will be 0 and your x is 40, right? Now this is a vertical straight line. So on this point the coordinate is 40, 30. Now this is a vertical line, so x coordinates will be same. So here if it is 40, here also it will be 40. And your y is 30, right? And here your y x is 0 and y is 30, right? So this was 0, this will also be 0, and this is a horizontal line, so y coordinates will be same. Now you know in horizontal line y coordinates will be same, and for a vertical line x coordinates will be same, right? Now let us write, this is first element, second element, third element, fourth element, and node, this is first node, so node I am circling the node. This is second node, this is third node, and this is fourth. I have put a circle for node representation, and for elemental representation there is no circle, right? Now what else is given? So forces are given. There will be some load which is applied on the truss element. So because of that load, displacement and stresses will be there, right? So what is the force? Here you can see there is a vertical arrow. Maybe from next videos I will use different type of ink so that it will be easy. I will highlight this one. So this is one vertical load of 25 kilonewton, right, which is acting on third node. And there is a horizontal load which is of 20 kilonewton, right, and acting on second node. Now when we saw the basic definition of truss elements, we found that there will be only axial forces, right? Now if you see these forces, can you determine whether it is axial or not? Yes, it is axial because it is along the axis of this element, right? Along this axis, right? So these are axial forces, hence there is no problem in the question. Now we are going to solve the question. So the next data which is given is E. E is nothing but Young's modulus, 200 GPa. Now from this Young's modulus you can find that this is steel. A is nothing but 100 mm square. Now here is the point, here is the major point which you need to remember. The units play a major role in our mechanical engineering, right? So even if the units change and your calculations are correct, the final answer will be different. Now this is in mm square, but this is in gigapascal, so you have to convert it, right? So what I suggest is, you if any of the other things are given in mm, no, so Young's modulus you take in megapascal, right? I will tell you how. So 200 GPa, if I need to write in megapascal, it will be 2 into 10 power 5. 2 into 10 power 5 megapascal. Yes, correct. Because giga is 9, so you need 3. So 3 plus 2, 5. So 2 into 10 power 5 megapascal. I will tell you, don't worry, right? Now, in mega means 10 power 6 and giga means 10 power 9, right? So if you have to make giga as mega, you will write 1000 into 10 power 6, right? 1, 2, 3 and 6, 9. 1000 into 10 power 6. So this is nothing but megapascal. 1 giga is equal to 1000 into 10 power 6 megapascal, right? So this 1000 is this 1000 and this 100. If we multiply, it will become 1, 2, 3, 4, 5. That's why I have written 10 power 5. So 2 into 10 power 5 megapascal, right? And one important thing is 1 megapascal is equal to 1 Newton per mm square. Now this unit, it is in mm. That's why I told you keep it in megapascal. If it is in megapascal, you won't make any mistakes, right? So far it is clear, I guess. Now let us see the steps forward, right? So on the next page you can see the steps, right? So step 1 is nodal data. What is nodal data? I told you there are 4 nodes: node 1, node 2, node 3, node 4. Now you have to write the coordinates of that nodes. That is nothing but nodal data. So x coordinate, y coordinate. So for first node, you see here, I have told you, it is given 0, 0. So you have to write as it is. You don't have to do any calculation. 0, 0. So for second node, x is 40, y is 0. X is 40, y is 0. For third node, you see here, for third node, x is 40, y is 30. So x is 40, y is 30. And here for the fourth node, x is 0, y is 30. X is 0, y is 30. So this is how the nodal data table is filled. So first step is easy. You have done it. Now second step. What is second step? Elemental connectivity table. Now this is the step where you have to do few calculations, right? Let us see this. Then I will tell you some basic things about this figure, right? We'll complete step 2 and then we'll go back to the figure. Elemental connectivity table. Now elemental connectivity table, what will be there? Element number, initial node of element, final node of element, LE, length of element, L and M, right? Now what is initial and final node? Let's see if this is your pen, right? This is one element. So it is starting from here, there is one node here. So this is initial node, and at the end there is one node. So this is final node. This way. So initial node, final node. Similarly, element 1. Now see this figure. This is your element 1, right? So initial node is 1. Final node is 2. That's why you have written initial node 1, final node 2. Let's see this two columns first. So for second element, your initial node. So from 1 to, now you will go like this, 2, 3. So initial node is 2, final node is 3. So 2, 3. Now you are going like this. You came here. So for third, initial node will be 3, final node will be 1. It won't be 1 and 3. It will be 3 and 1. So initial node is 3, final is 1. This is tricky. Like when I studied this, I got the doubt that why the initial node is 3. Why the initial node is not 1? Because see, you are going in this order. So you have to follow the order. 1, 2, 2, 3. Then it will be 3, 1, not 1, 3. Because the order, it is disconnecting. So it should not disconnect. It should be connected. 1, 2, 2, 3, 3, 1. So for third element, your initial node is 3, final node is 1. And for fourth element, your initial node is 3 and final node is 4. So this is your fourth element, right? So I hope these two columns are clear, right? Now let us see LE. Now we have seen the formula earlier. What is the formula? LE is equal to, yes, correct, square root of x2 minus x1 whole square plus y2 minus y1 whole square. Are you able to see the formula? No. So I have to shift page so that you can see. I hope you can see now, right? Yeah, so what is LE? LE is nothing but x2 minus x1 whole square plus y2 minus y1 whole square. So for element 1 you have to find LE, right? Now here x2 is nothing but final node, x1 is initial node, y2 is final node, y1 is initial node. Now let us see where is element 1. This is element 1. I hope you can see element 1. Final node, initial node. Final node, what is the x coordinate? 40. So I have written 40. Initial node, what is the x coordinate? 0. So I have written 0. 40 minus 0 whole square plus final node of y. Final coordinate of y is 0. So 0 and initial coordinate is 0. So 0 minus 0. y2 minus y1 is 0 minus 0. And when you solve this, you will get LE is equal to 40. So only I have written LE is 40 here, right? Now you got LE. Now you have to find L, right? So L, what is the formula? x2 minus x1 by LE. x2 is nothing but here. This element x2. 40. x1 is 0 here. 40 minus 0 by 40 is equal to 1. So only I have written L is 1. M, y2 minus y1 by LE. y2 is 0. y1 is 0. So 0 minus 0 by 40 is equal to 0. So only I have written M is 0. So similarly, LE, L and M, you have to calculate all the three for every element. So for first element I have shown you, like second you have to do, third you have to do, fourth you have to do. So for example, I am giving element 3. Element 1 and 3 I have solved, right? So I will show you element 3. I hope you are able to see. If you can't see, I will shift the page. Now you can see, yes. So L is nothing but, now what I told you, for element final minus initial. For element 3 also it will be final minus initial. But the final and initial nodes are changed. See, final node is what? 1 and initial node is 3. So it will be x1 minus x3. So formula is a little bit tuned up, right? You have changed it. So final, the basic formula is x final xf minus xi initial. So this is the basic formula. So final is x1 and initial is x3. So x1 minus x3 whole square plus y1 minus y3 whole square. What is x1? x1 is, you can see this nodal table or you can see the figure, whichever is convenient to you. So x1 is nothing but node 1 ka x, 0. x3 is nothing but node 3 ka x, 40. 0 minus 40 whole square plus y1 is nothing but node 1 ka y, 0. y3 is nothing but node 3 ka y, 30. So 0 minus 40 whole square plus 0 minus 30 whole square. LE will become 50. When you solve this, since it is square, the negative term will also become positive. LE will become 50. So only I have written LE 50 here. Now to find L, why I took element 3? Because see, this was a bit different part, x1 minus x3. So only I told you element 3. So element 2 and 4 will be easy because I have told both positive and negative values. This here you got all the positive values. Here L and M is negative. I'll tell you how. So L is nothing but what? Here it was x2 minus x1 because 2 was final, 1 was initial. Here 1 is final, 3 is initial. See here 1 is final, 3 is initial. That's why we have drawn this elemental connectivity table so that it becomes easy to you to find which is final node and which is initial node. Once you calculate or once you figure out which is final and initial, you just have to look into the table and write the values. So final is 1, x1, initial is 3, x3, x1 minus x3 divided by LE. x1 is what? 0. x3 is what? 40. 0 minus 40 by 50. The value is minus 0.8. So only I have written here. You can calculate, I can show you. So this is your calculator. I hope you can see. Minus 40 divided by 50. It gives you minus 4 by 5. Which is nothing but minus 0.8. So I have written minus 0.8 here, right? And m value is y1 minus y3 by LE. So y1 is 0, y3 is minus 30. Wait, y3 is not minus 30, the minus is here, y3 is 30. So 0 minus 30 by 50, the answer is minus 0.6. So I have written here minus 0.6. Okay, no confusion so far. So element connectivity table like this, you have to fill LE, L and M for all the 4 elements, right? So you can take your time and fill, otherwise I have given you the solution. You can take the screenshot of this page, right? Now what I was telling you, I missed something during the explanation of this figure, right? Now I will tell you what is the explanation. Let us zoom. Yes, so you can see this figure, right? I have zoomed the figure. Yes, now I told you there will be displacements in horizontal and vertical direction. Now this is the node. If you are applying a load on it, there are possibilities that it can go, the displacement can change to horizontal or vertical, since there are 2 degrees of freedom, right? So for one, if you take in terms of displacement, it will be, I am telling q1 in horizontal q1 is the displacement in horizontal direction and q2 is the displacement in vertical direction. I am telling this for first node, first node only. And in terms of forces, F1 is horizontal, F2 is vertical. Now to tell a trick, I will tell you a trick. All these odd numbers, odd numbers 1, 3, 5, it will always come in horizontal direction. Now this is how you have to remember. You can tell that, see, okay. So you can tell that I will write F2 here and F1 here. No, this is not the right way. Always for horizontal, odd numbers will be there. So these are the standards which you have, like you need to follow. Everyone follows that, right? So on horizontal it will be 1, or you can say odd numbers, and on vertical it will be even numbers. So for first node q1, q2. For second node it will be it is ending on q2, no? So it will start from 3, q3, q4, or you can say f3, f4. For node 3 here it is q5, q6, and for node 4 here, see here, node 4 it is q5, q6. Now it will be q6 and q7 and q8, right? So I told you there are 2 degrees of freedom and there are 4 nodes. So 4 to the 8. It will end at 8. Q8. Okay. So this is how you can check. So whatever we are doing is right. Q1, Q2. For node 1 it is Q1, Q2. Node 2 Q3, Q4. Q5, Q6. Q7, Q8. Similarly F1, F2, F3, F4, F5, F6, F7, F8. Right? Now why I am telling this, because see your force is given here in this direction, in horizontal direction, and it is on node 2. So it is which value, F3 or F4? It is in horizontal, no? So F3. So you got F3 is equal to 20 kilonewton, and we know this towards right side it will be positive and towards left side it will be negative, right? The representation. Are you able to see? Okay. So towards right side it is positive axis, and towards left it is negative, and towards down it is negative. The force is downwards, and if the force is upwards is positive. So this 20 kilonewton is nothing but F3, because it is acting on vertical direction on node 2. So on node 2, it is acting on horizontal direction on node 2. So on node 2 horizontal direction is 3. So F3 is 20 kilonewton. Can you tell me this 25 here? Here this 25, it is vertically downwards and it is acting on node 3. You guess. Let us take few seconds. Let me give you hint. It is F5 or F6. F5 or F6? Yes, you got it right. This is F6, right? Because it is vertical. See, vertically downwards. So Q6, F6, force representation F6. So it is F6 here. Yeah, F6. And will it be positive or negative? So if it is upwards, it's positive. Downwards, it will be negative. So F6 is minus 25 kilonewton. So what all values you have? You know E, 2 into 10 power 5 megapascal. You have converted. You know A, 100 mm square. You know F3, 20 kilonewton. And you know F6, minus 25 kilonewton. Now these are the values which is enough to find the nodal displacement and all the other values, right? So far it is clear. So first is you need to write down all the values what you know, known data, then nodal data, elemental connectivity table. Step 2, yes. So let us stop here and see the next steps in the next part.